Which of the following expressions are polynomials in one variable and which are not? State reason for your answer. The first question is 4x square minus 3x plus 7. You see here in this polynomial, x only is the variable. X only is the variable. Therefore, this is a polynomial in one variable. In one variable. In the second example, y square plus root 2. Here 2. Here y is the variable. Y is the only variable. Therefore, it is a polynomial in one variable. In this example 3, this can be written as 3 t to the power of 1 by 2 plus t root 2. It looks as if it is a polynomial of one variable, but the power of t is half, that is 1 by 2. The power of t is 1 by 2, which is not a whole number. Half is not a whole number. Therefore, the equation is not a polynomial. Let us take this fourth example, which can be written as y plus 2. When this y moves to the numerator, its exponent changes to, here in the y to the power of 1 is there in the denominator. When this y to the power of 1 moves to the numerator, it changes to minus 1. Here also we can write minus 1 is not a whole number. Not a whole number. Therefore, this is not a polynomial. As you all know that the polynomial can have only the whole number as the exponents for their variables. Whereas in the fifth question, here you will be seeing x to the power of 10 plus y to the power of 3 plus 3 to the power of 50. Whereas here all the variables are having the whole number as their exponents. Yes, this is no problem. But here the problem is with the x, y and t. All the three are variables. That means here there are 3 variables: x, y and t. Therefore, this is not a polynomial. in one variable. You see, in this case, the exponents of the variable is not a problem. All the three numbers are all having the whole number as their exponents. That is not a problem, but the three variables are the problems. Whereas in this case, here to here the exponent itself is the problem. So this is not a polynomial. Here too, root of t, square root of t. So square root of t can be written as t to the power of 1 by 2. 1 by 2 is not a whole number. Therefore, the equation is not a polynomial. But here we should note that the fifth example is the polynomial with three variables. This is a polynomial with three variables. This is a polynomial. Definitely this is a polynomial, but with three variables. Write the coefficients of x square in each of the following. First one, 2 plus x square plus x. Here, x square is, the coefficient of x square is 1. Here, it is not been written. So, we can directly write 1 is 1. In the second problem, 2 minus x square plus x cube. This can be written as 2 plus of minus 1 into x square plus x cube. Plus into minus is minus. So, the coefficient of x square is minus 1. What about this case? In the third case is pi by 2 x square plus x. So, in this case, pi by 2 into x square, that is coefficient of x square is pi by 2. In this case, in the fourth case, here there is no x square. In this polynomial, there is no x square. Therefore, coefficient of x square do exist. You can't say that it doesn't exist. This can be written as, this equation can be written as 0 x square plus square root of 2x minus 1. Therefore, coefficient x square is 0. Coefficient of x square is 0. Give one example each of a binomial of degree 35 and of a monomial of degree 100. Firstly, we will give the example of binomial of degree 35. That means x to the power of 35 plus 2 is the example. And you can write, let me give the first example, this let it be second. Let me try to give another for the best understanding. Y to the power of 35 plus y. Here the degree of the second term is not considered, as the maximum degree must be 35. We can give another example. Z to the power of 35 plus z to the power of 34. There is only two terms, that is binomial. The binomial should have two terms, and the maximum degree of the variable, maximum exponent of the variable must and should be 35. Now let us consider monomial of degree 100. Monomial means it should have only one term. That means x to the power of 100. This is a simple example. Let us make it some more complex. The second example can be written as 240 x y to the power of 100. Other than this exponent 100, you can't get anything else. So we can make pi by 45 z to the power of 100. This also holds good. Likewise, here it has been asked only one example. We have given here three example for the binomial of degree 35. All the three examples are there. Monomial of degree 100. Here also there are three examples for the better understanding. Write the degree of each of the following polynomials. 5x cubed plus 4x square plus 7x. Here x is the variable and the maximum power of x is 3. The maximum power of x is 3. That is, the maximum exponent of the variable x is 3. Therefore, degree of this equation, of this polynomial, is 3. In this case, y is the variable and the exponent of y is 2. Therefore, degree is 2. Here in the third question, 5t minus root 7. The t, first term 5t, t is the variable and t to the power of, there is nothing, that means it is there. We should assume that t to the power of 1 is there. Therefore, degree is 1. Degree is 1. In this case, we can write this as 3 is equal to 3 x to the power of 0. 3 x to the power of 0. As we all know that x to the power of 0 is equal to 1 x to the power of 0. If not, you can write y to the power of 0. That is, you can also write 3y to the power of 0, where y to the power of 0 is equal to 1. So, here if you write like this means the variable is x. If you write like this means the variable is y. We need not worry about the variables. We need only the exponent. Therefore, the exponent in both the cases is 0. Therefore, degree is 0. Degree is 0 in the fourth case. Classify the following as linear, quadratic, and cubic polynomials. Your first question is x square plus x. X square is the one term and x is another term. That means there are two terms in this polynomial. So it is a quadratic polynomial. Quadratic polynomial. Here also x is first term and minus x cube is the second term. So there are only two terms in this polynomial. So it is also quadratic. Here there are three terms. Y is the first term, y square is the second term, and 4 is the third term. So it is a cubic polynomial. Here there are only two terms, 1 plus x. So it is a quadratic polynomial. Here fifth question is 3t. 3t is having only one term. That means it is a linear polynomial. R square is the sixth example. That is, it is also having only one term. That is, this is also linear polynomial. 7x cube is the only one term in this seventh question. That means it is also a linear polynomial.